All right, hi Math9 students. We're going to do the second part of the recording now. We started it the first half yesterday. Actually, this part won't be a whole half. This will probably only take us 10 to 15 minutes to finish up, which is good news. Hope you guys are doing really well. I know it's cold these days. Not really looking a whole lot like spring, but hopefully in the next week things are going to turn around. Last night, all three of my teams in the NHL won their hockey games. I like the Oilers. I still like the Montreal Canadiens because I grew up in Montreal. And also like the Canucks. They're a Canadian team and they're going for it. So, first place in the league. So anyways, let's get into this stuff. We're going to talk about transformations. And as you can see from this picture of Superman, I don't know if you guys have watched the Superman movie, but the word transform means to change, and of course Clark Kent, we all know that with Superman he would go into a telephone booth and then magically, rip off his shirt and become Superman. So anyways, when we're talking about transformations in math, we're talking about maybe not quite the same thing, but we're talking about changes. And we're talking about changes in objects that are on a grid, like an X and Y grid, right? So we're talking about four basic types of transformations, and they're translations, reflections, rotations, and dilatations. And so let's just review briefly what each one of these is about. So first of all, we have a translation, and a common word for translation is a slide. So that's when an object moves left or right, or up and down to another location. And a lot of times when you have a translation, you're moving both left or right and up and down. So you're combining two movements when you do the translation. So that's what a translation is. Now a reflection is simply a flip, as we can see here. So it's when an object is reflected in the same way an image is reflected in a mirror. So of course you can always imagine a reflection line just like a mirror, and you can imagine that this skateboarder has been twisted around when he does his flip. The next transformation is a rotation, and so this is a turn when an object is rotated at a certain angle. We'll talk about those angles later on. Now a dilatation is when an object is either made larger or made smaller. So earlier we were looking at scale factors and things like that on the first recording, and we saw that dilatations include both enlargements, like this here, and reductions. So both of those are dilatations. Okay, so again, please practice all the blue questions and make sure you can get them on your own. And so we're going to do a blue question right now. The question says, triangle ABC has these coordinates here, and it is translated 6 units to the right and 2 units up to form A prime, B prime, C prime. That's what these little hash marks mean. And remember, whenever we have those primes, that represents the new image. So in this case, it's a new triangle. So it says find the coordinates of A prime, B prime, C prime. All right, so the first thing, of course, we have to do is to plot the original triangle or image on the graph. And so we use the coordinates we're given here for the original triangle, and we plot them on the graph. Then we use the fact that we're translating the triangle, all 3 points, A, B, and C, we're translating them 6 units to the right and 2 units up to get the new image. Now there's a mistake here on the graph. It says 5 to the right. It should be 6 to the right, and then it's 2 up. So we know that the new triangle is somewhere up here. And it's good to know approximately where it is, but we want to know exactly where it is. So how do we find exactly where it is? Well, let's just review what it means to move something 6 units to the right and 2 units up, and how that's going to affect the X values and the Y values from this original image. Okay, well we know that to the right means positive on a graph, so we are going to add 6 to each X value. So let's just review what a graph is going to look like. So here's our graph, and we have the x-coordinate and the y-coordinate, and we know that the x values are going to be positive to the right and negative to the left, and we know that the y values are going to be positive as we go up, and the y values are going to be negative as we go down. So, just focusing on what this means, going to the right, if we're going to add 6 to each x value, we're going to be going this way. And when we're talking about 2 units up, up means positive, so we're going this way. Okay, so what we do to get our new x and y values, here's the points that we had originally, and we can see that we're adding 6 to each x value. We're going 6 to the right, and we're adding 2 to each y value. So we do the same thing to each x and y. We add 6 to the x's, 2 to the y's. So when we add 6 to the x's, we started with 5, we add 6, we get 11. With the y's, we started with 7, we add 2, we get 9. So that's how we get our new point A, which is A prime. We do the same thing for B. We get the new B prime values, and C. Okay, so we get new values for A, B, and C by adding 6 to the x, 2 to the y. Now we can plot these new values on the graph, because that's what the question was asking us to do. So you can see that for point A, it was 11, x was 11, y was 9. You can see you go over here, x is 11, and you see your new value right there for A. Y was 9. If you go over here, you can see it's 9. Okay, so that's how we get our new image. And again, we label it A prime, B prime, C prime. So that's what we needed to do, was find our new image. We did the math, and then we plotted the new image on the graph. And you can see that it's translated to the right, and it's translated up. All right, good stuff. Now, one more thing to notice when we're talking about translation. The original question said we were going 6 units to the right and 2 units up. And I want you guys to notice that another way of saying what you see in words here is this here. This says each x value is going 6 units. It's going to be 6 units greater in the translation, and each y value is going to be 2 units greater. So when you get a question, you could either get it this way, where you've got words to describe the translation, or you could get it this way, where you've got numbers. Both are saying the exact same thing. Okay, so let's go on to reflections here. We've got another question. This one says, right triangle ABC has these coordinates here. It is reflected through a line that cuts the x-axis at x equals 11 to form this new triangle. So as usual, we need to find the coordinates of the new triangle. Okay, so we're going to have to do some sort of math to find the coordinates, and then we're going to plot the new triangle. It doesn't actually say to plot it, but you might have to plot it, so we're going to look at that as well. Now, here's the key. The key to solving a reflection problem is to determine how far the object is away from the reflection line. So once we figure out how far each point is, we figure out point A is a certain amount away from the reflection line. That's how far away the new point A prime is going to be on the other side of the reflection line. So first what we do, as we did with the other one, we plot the original image points, A, B, and C. So we've plotted them here. Then what we need to do is to draw our line of reflection. So our line of reflection cuts the x-axis at x equals 11. Now, it's not really perfect here because sometimes you can't line these up perfectly. It should be right here. It should have been drawn right here. But so at x equals 11, we draw a line. Because this whole line is x equals 11, right? We just have different y values. Okay, so we know what our line of reflection is. Now we need to figure out how far each point is from the line. Now if you counted them out, you would find that point A is 8 units away from this reflection line. So where's A prime, our new point, going to be? 8 units on the other side of the reflection line, right here. Same thing with B. B is 3 units away. B prime is going to be 3 units away. Same with C. It's also going to be 8 units away. So let's see what our new reflected triangle looks like. It looks like this, just like you'd expect it to look, right? And you can see that B and B prime are the same distance away from the reflection line. Same with A and A prime, C and C prime. Okay, so that's how we do a reflection. The last one we're going to look at is rotation. And of course you guys are familiar with terms like clockwise, counterclockwise. This is the direction the hand moves in a clock. It's clockwise, sometimes we just call it CW. Counterclockwise, CCW, the opposite direction. Okay, another thing we just want to go over briefly. This is a 90-degree angle clockwise. This one's 90 degrees counterclockwise. And so of course that's a 90-degree angle, just like the angles you see all over your room. You know, if you look at a book, you know, 90-degree angles are everywhere. On the other hand, a 180-degree angle is like a line. It's a complete line. And so this is counterclockwise, this is clockwise, and 270 degrees, as you can see, is more than a line, more than a straight line. It's another 90 degrees on top of that. So the other thing to know is that when we talk about rotations, we talk about rotating around a certain point. Sometimes that certain point that you rotate points or objects around will be the point right in the middle of the X and Y grid, which is called the point of origin. So this point right here is the origin, and it's 0, 0. It's not always the case though. Okay, so let's just review. There's a few things you have to do when you rotate any figure. So you need to be told what figure is rotated. So that could be just a point, like point A, B, or C, or it could be a whole image or object, like a triangle. You need to be told the number of degrees. So is it 90 degrees, 180? And then the direction that you're rotating it. So you need to know all those things. Now also, I didn't mention here, but we also need to know what point you're rotating it around. Is it the origin or something else? So let's assume it's the origin for now. So here's a point, and if you were rotating around the origin, here's the easy way to figure out where the new point is going to be. If you were rotating this point 90 degrees around the origin, what you do is you draw a line from the point to the origin. Then you draw a 90-degree angle. And you can see this is a 90-degree angle. And so this then is going to be your new point. As long as this line is equal to this line, this is your new point. And it makes sense that it's 90 degrees clockwise. This is clockwise direction. And here's where the 90 degrees comes in, this angle right here. Okay, so that's how you rotate a point around the origin and how you figure out the angle. You draw a line from the point to the origin. But what happens if you're not rotating the point around the origin? What if you're rotating around something else, some other point? That's what we have in our next question. So this question says, if triangle ABC was rotated 90 degrees clockwise around point D, then the coordinate C prime would be, okay, so we only are interested in finding out what the new coordinate for C is going to be. So last time we would have drawn a line from C to the origin if we were rotating C around the origin. But since we're rotating C around point D, instead we draw a line from C to D. But just like we did before, if we're doing a 90-degree rotation clockwise, we're expecting that we're going to rotate it in this direction. So our new point is going to be somewhere over here, right? So what we need to do is we need to draw a 90-degree angle. and you could use a piece of paper to do that. If you have a protractor, that would help as well. We know roughly what a 90-degree angle looks like though, right? Something like around that. Okay, so at this point then you can figure out which of the following is most likely to be the new point, since we know that it's been rotated 90 degrees. Okay, so which point do you think it's going to pass through? So you're going to pass through 6, comma, -2, 1, comma, -3, or -1, comma, -3, or -6, comma, sorry, -2, comma, 6. Okay? So you guys can figure that out. All right. So again, first step, draw a line from D to C, then make a 90-degree angle with this line to find the point. Okay, last thing we're going to look at, we've already looked at dilatations. We saw that those are either where you enlarge an image or reduce the image, and so you're always using the scale factor. And if you remember back when we were looking at these different triangles, we would try to figure out the new length of a side by figuring out the scale factor. So for instance, all the sides on a triangle could be twice as large, and in that case the scale factor would be 2. Or if you're going the other direction, it would be 1/2. So when we looked at translations, we would look at the original points and we would add a certain amount to each point, the x and y values. With dilatations, we're always multiplying, or we're dividing by a certain number. Well, actually you could say we're always multiplying, because we either multiply by something like 3 if we're enlarging the image, or we multiply by something like 1/2. It's the same thing as dividing in the other direction if you want. But so in this situation, our scale factor is 3. We're enlarging the image, so we multiply both the x and y values by 3. 2 times 3 is 6. 2 times 3 is also 6. You can see where you get the new value for A, also for B and C. Okay, so dilatations are pretty straightforward. Just multiply by the scale factor. All right, so guys, that's all there is. And I want you guys to please watch these recordings carefully, practice all the blue questions, and you should do well on the test, which is going to be next week, and it covers lessons 17 to 24. So please continue to work really hard, guys. Take care and have an awesome day. Bye for now.